2.4 is linear functions. A linear function is mx plus b. So this, let's make a note. Is degree 1. And mx plus b, let's say m does not equal 0, and b is any real number. The domain and range are both all real numbers, so that's that capital script R is for all real numbers. And we still have a linear function if m equals 0. If m equals 0, then the function is just b, which is a constant. So that's going to be a horizontal line on the graph. Now, if you have a horizontal line, the domain, which is the set of all valid inputs, the x values, that's still all real numbers, but no matter what input you give the function, your output is just going to be the y value of, in this case, I am using the letter b. This is going to look familiar to y equals mx plus b, which is slope-intercept form of a line. And we talk a little bit more about that here coming up in the next section, actually. So, about the easiest thing we can do here, graphing lines, no matter what, to graph a line, you find two ordered pairs and connect them by drawing a line through them. And so keep in mind that that's it. That's all we need to graph any line ever. We can get kind of convoluted talking about various things on how to graph lines, like using the y-intercept and the slope and all of this stuff, but it all boils down to no matter what line you need to graph, you just need to find two ordered pairs and then plot them. So let's talk about the intercepts. The y-intercept for any function is f of 0. And then the x-intercept, as we know, for any function is, we set 0. We set the function equal to 0. So the x-intercept as an ordered pair is negative b over m, comma 0. Now, since a line with a non-zero, since a line is degree 1, so it's linear, whether it's a horizontal line, which a horizontal line is actually degree 0, a non-horizontal line, non-vertical line also being degree 1, we have one y-intercept and one x-intercept, so it'll cross the graph exactly one time on the y, exactly one time on the x. So let's look at f of x equals 3x minus, let's do 12. So f of 0 is 3 times 0 minus 12, which is negative 12. So 0, negative 12 is the y-intercept. And 0 equals 3x minus 12. That's going to give us x equals 4. So 4 comma 0 is the x-intercept. So those are special points on the line, but we don't necessarily just have to find the intercepts in order to graph a line, what we do need to make sure of is that we label properly anywhere along that line, and do your best artwork, but labeling is the most important part. We don't need 12 tick marks down here on the graph in order to communicate. We just need to label those 2 points. So let's find some more ordered pairs. We can pick any element in the domains. The domains are real numbers, so let's maybe say if we pick x equals 1, 3 times 1 minus 12 is negative 9. So that as an ordered pair is 1 comma negative 9. Let's do maybe 7. So 3 times 7 minus 12 is 21 minus 12, which is positive 9, so 7 comma 9. Maybe let's do 10, which is 30 minus 12, which is 18. So we can just keep finding points on this line, but we need only 2 to graph that line. Not so bad. Let's talk about slope. Now, slope is not an angle, it's not inclination or anything like that. Definitely avoid using something like rise over run. That's nonsensical. Slope is the change in the dependent variable per unit change in the independent variable. And we denote this using n. So the change in the dependent is the y, and the change in the independent is the x, so we can use delta notation. And for a line, we need just the slope formula, because the slope, and I'm going to say rate of change, that rate of change is a much better it's a much better term than slope. Of course, you know, slope is the conventional term, but rate of change is more descriptive and it's better for learning purposes when we start. So the rate of change of a linear function between any 2 points is always the same. So all we need is to find the slope of a line is we just need the knowledge of two ordered pairs on that line, and we can find the change in y over the change in x. Any 2 points will work, because on a line the rate of change is always the same between any 2 points. Okay, so we have the function 6x plus 1, and I think most of you watching this probably already know that the slope is going to be 6 from, slope-intercept form of a line. The book introduces linear functions first and then gets more in depth about the equations of a line. I think it should probably be the other way around, but we're just going to look at finding the change in y over the change in x using 2 points, and then we know that we're going to end up with m equals 6. This is, to display how this works. So the change in y between either of those 2 points, it doesn't matter which you think of, you want to start with. And actually, let's draw a little graph here. Let's say that this is 19, and this is negative 11. So if we go from 19 to negative 11, we have a change in y of negative 30 because we went down. So, and then the change in x, let's take a look at that. If we went from 3 on the x to negative 2, delta x equals negative 5. So if we're 3 on the x, and then we go to negative 2, we're moving in the negative direction. So on the horizontal axis, left is the negative direction, on the vertical axis, down is the negative direction. So delta x is negative 5. So m is delta y over delta x, which is negative 30 over negative 5, which is 6. Between any two other points, or if you had started at negative 11 and thought of it as moving in the positive direction on the y to positive 19, and then starting at negative 2 on the x, moving in the positive direction to 3, it's going to always reduce to 6 between any 2 points on the line. Now, we're learning about how linear functions work and all of that. So this is a learning way, a teaching way to think about rate of change. Rate of change is extremely important. Understanding how independent and dependent variables in linear functions work together. Y depends on x, so if we can understand rate of change, how much does y change per unit change in x? Well, what this says is six units change in y per unit change in x, and that's rate of change. You can use the slope formula and simply just plug it in, but I wanted to display where this stuff came from. So now talking about two different types of slopes that are not just non-zero real numbers. So if the change in y is 0, then we have the slope of 0 over delta x, which is 0 divided by any non-zero number, is 0. So what that says is for any change in x, there is no change in y. And this is a horizontal line. So if we take a look at like f of x equals 8, and you graph that, now graphing a horizontal line, since you know the slope is 0, any 2 points will do. We know that the y value is always going to be 8 for f of x equals 8. There is no change in the y value, so if we go from -2 to 0 and our delta x is 2, our delta y is still 8. So m would equal 8 minus 8 over -2 minus 0, which is 0 over -2, which is 0. So it's important to understand what a slope of 0 tells us. It doesn't matter how much we're changing the independent variable, we are not going to get any change in the dependent variable. This logically leads us to, okay, well, what if there is no change in x? So if there's no change in x, the line doesn't fit the definition of a function, and this is a vertical line. So, just graphically, if you have a vertical line, there's no change in x, no matter what. In this case, x is always 4. So if there's no change in x, that means every ordered pair is going to have 4 as the x component. Now remember, the definition of a line is for every valid input there exists a single possible output. Well, if we were to say that 4 is a valid input, assume, and then by way of contradiction, let's show that this is not a function. And I know that you're looking at it graphically and you already know the vertical line test and things like that, so this should make sense. Assume that 4 is a valid input into a function, a well-defined function. If that's the case, then there should be only one y value paired with x equals 4. Well, there's our contradiction, because this vertical line, since there is no change in x, is going to be paired with, in fact, every y value from -infinity to infinity. So this relation, it is not a function, this relation has a domain of 4, and it has a range of all real numbers. And this would be an undefined slope. So vertical lines have, please don't write 0 in the denominator. Don't write m equals and then a number divided by 0. The vertical lines have undefined slope, and that's all we need to say. We don't need to try to write m equals this or that. And again, please don't write 0 in the denominator. Division by 0 is undefined, and so we just avoid writing that, and because it looks silly, and it also, of course, doesn't make sense. So vertical lines are not functions, and that makes vertical lines very easy to graph, but they're not functions, so we don't call them f of x equals, whatever. Remember, y and f of x are the same thing. So if you said f of x equals 4, you're saying y equals 4, that would be a horizontal line. Okay, so just to recap, to graph a line you need 2 points. Horizontal lines have a slope of 0, vertical lines have undefined slope, and we developed the concept of rate of change and the slope formula.